Today we're going to be talking about deriving quadratic functions, and we're going to have the bonus of word problems. Hooray! Alright, so let's start with this. We'll be deriving quadratic functions giving different pieces of information. You will need to decide which form will be most beneficial based off of what information you're given. Now the two different forms we might be using are Vertex Form, which we've learned about earlier. That's y equals a times x minus h plus k, where we need the a value in the vertex. And we can use that when we're given the vertex in another point, at which point we'll have to find our a value. Then our second form that we might be using, behind door number 2 as it were, is standard form, which is y equals ax squared plus bx plus c. We use this when we're given just 3 points. We'll then have to find a, b, and c, and we have a couple ways of doing that. So now what we're going to do is write the equation for the quadratic function that satisfies the given information. So let's look at this and decide which version we're going to want to do. So here's our first problem. We have a vertex and a point. Now since we only have 2 points and one of those points is a vertex, that means we will be using vertex form. So the first thing I always do is I always write vertex form written out with the part I have, which is the vertex. So our h value, just a reminder, is the x value in the vertex, so minus 2 squared plus 1. You don't have to write this part, but I like it because it helps me later on. Now I'm going to plug in some values. So the only value I have besides my vertex is my point, so I'm going to plug that in. The y value in the point is 5, so where I see the letter y, I'm going to write 5 equals a times, in this case, 0 minus 2 squared plus 1. Now as we know, 0 minus 2 is negative 2, so negative 2 squared is 4. So that means that 5 equals 4a plus 1. Now what I have to do is I have to subtract my 1. That means 4 equals 4 equals 4a, which means a equals 1. I'm going to take that information and plug it right back in to the original equation, getting me y equals, remember, whenever we multiply 1 by something, we don't have to write it, so just x minus 2 squared plus 1. All right, let's try another equation. In this case, remember, our h and k are 2 and negative 7, so I'm going to write y equals a times x minus 2 squared minus 7. So instead of y, I'm going to write 1. Instead of x, I'm going to write 0. 1 equals a times 0 minus 2 squared minus 7. So 0 minus 2 in this case is negative 2 squared, and negative 2 squared is 4. So 4a minus 7 equals 1. At that point, we add 7, 8 equals 4a, divide by 4, 2 equals a. I'm going to bring that back up to my original equation and plug it into where it's y equals 2 times x minus 2 squared minus 7. And that would be our final equation. Okay, let's try this one right here. All right, so in this case, our vertex is 3, negative 5. So this becomes y equals a times, I'm just going to put in my values this time, 2 minus 3 squared minus 5. So, wait, I should also say, instead of y, we're going to put in 0. At which point, 2 minus 3 is negative 1. Negative 1 squared just becomes a minus 5 equals 0. Add 5. 5 equals a, which means our final format is y equals 5 times x minus 3 squared minus 5. So, on this slide, I'm not going to actually do it necessarily because we've already done a few examples, but I do want to point out one important thing. Right here it says exactly one x-intercept. So there are 3 ways that quadratics can go. One way is when they do not touch the axis, at which point there are 0 x-intercepts. Another way is where they pass, at which point there are 2. And finally, there's one where it just touches the axis, and that is when there is 1. That means that this point right here would be a vertex. But like I said, we're not going to talk about that right now. So, now let's try talking about, though, what happens when we have 3 points. Now, since we have 3 points, we can't use vertex form, and instead we have to use standard form. So that is y equals ax squared plus bx plus c. Now, the problem is I do not have any x values. So instead, I don't have any a, b, or c values, so I have to plug in my x values. Here's our first one. A times negative 3 squared plus b times negative 3 plus c equals 0. Now let's try that. Again, a times, not negative 2, 2 squared plus b times 2 plus c equals 0. And finally, a times now negative 2 squared plus b times negative 2 plus c equals negative 2. At which point our final versions are 9a minus 3b plus c equals 0. On the next one, 4a plus 2b plus c equals 0. And finally, 4a minus 2b plus c equals negative 2. So once we know those, what we have here is a system of 3 equations. So I just plug those into my calculator using matrices: 9, negative 3, 1, 4, 2, 1, 4, negative 2, 1. And I would have that be my A. And then I'd do another one with my answers: 0, 0, negative 2. That's my B. Then I just do A, negative 1, B. When I do that, what I end up getting are 0.5, 0.5, and negative 3, which we would just plug back into our original equation. So y equals 1/2 x squared plus 1/2 x minus 3. And that would be our answer. Now let's try this where we're not writing as much stuff. So here's our first equation. What we're going to do here is we're going to write just our matrix. So remember, it goes x squared, x. Then our last row is always 1. Our other matrix is just our y, so let's put this in. negative 4 squared, negative 2 squared, 2 squared, negative 4, negative 2, 2, and then finally 1, 1, 1. 12, negative 14, and 6. When I put those into the calculator, I end up getting 3, 5, and negative 16, which means my final equation is y equals 3x squared plus 5x minus 16. It's that easy. But what if we wanted it to be even easier? Well, for that, we're going to have to go to this equation, and we're going to put it into a calculator, which will start now. So what we're going to do now is we're going to actually solve just using the stat feature. So you press stat, you go to edit, and then you choose our first point. Our first point was negative 2, 13. Our second point was not negative, it was just 1, comma, negative 17. Normally you would put all the x's and then all the y's, but I want to make sure that we're getting this. So our last point would be 731. Now we have our 3 points that we would do, and so I press stat again, then I go to calc, and then I'm going to choose quad reg. At that point, all the things that are currently set up as the naturals are fine. You press enter and you get your values. So in this case, when we use quadratic regression, it becomes a is 2, so 2x squared, minus 8x, and then minus 11. And now it's time for our favorite segment, Sports Talking! Hi, I'm David Peacock, and you know what? Let's talk some sports, because that's what I love. All right. Aaron Rodgers, a professional football player, I'm told, throws the football to one of his receivers. He throws the ball from 2 yards above the ground, and the ball beautifully flies 40 yards down the field, just barely crossing over one of the opposing player's hands, which is 3 yards above the ground. The receiver catches the ball 7 yards beyond the opposing player, when he is 1 yard off the ground. We need to write a function to represent the height of the ball in terms of the distance. And you know what? This is always easier when we draw it on a football field. So let's first start off with, here we have Aaron Watson. Apparently he is throwing this football, which seems kind of weird. But who am I to criticize? Oh, I'm sorry. I've been told that this is the wrong type of football because we live in America where we don't call it that. So we're going to try this again. So here's Aaron Rodgers, and he is holding the ball. All right. And he throws the ball. Now, if you look right around here, this is where we get the player almost catching it, but not quite. Aw, he's sad. And finally, right here is where his teammate, the receiver, catches the ball. And he is happy. All right, so let's put in some points here. Since this is where it started, it's at 0, but it is 2 yards up, as it says. Over here, this is 40 yards down, but that is also 3 yards up. And finally, he catches it at 47, 1. So now that we have those 3 points, all we have to do is plug them into our fancy little calculators, and we get negative 0.007 x squared plus 0.29 x plus 2. And that's our equation. And that's, of course, it for our favorite segment, Sports Talking. Tommy is training his dog, Sadie, to run across an arch ramp, which is the shape of a parabola. To help Sadie get across the ramp, Tommy places a treat on the ground where the arch ramp begins and one at the top of the ramp. The treat at the top of the ramp is a horizontal distance of 3 feet from the first treat, and Sadie is 5 feet above the ground when she reaches the top of the ramp. Write a function to represent Sadie's height above the ground as she walks across the ramp in terms of her distance from the beginning of the ramp. So, just like with the last question, I would recommend that we start by drawing an image. It doesn't have to be perfect. There's our ramp, right there. Now, here's our first dog treat, right there. And because that's right at the start, it's at 0, 0. Now, at the very top of the ramp is another dog treat, right here. And this one, as you'll note, is 3 over and 5 feet up, which means this one would be at 3, 5. So now all we have to do is place this into our formula like we've done before. So y equals a times x minus 3 squared plus 5, as we know the vertex in 1 point. Then I just plug in my values. 0 equals a times 0 minus 3 squared plus 5. At which point 0 equals a times negative 3 squared plus 5. 0 equals 9a plus 5. 5 equals 9a. A equals 5/9, meaning our final version should be y equals 5/9 x minus 3 squared plus 5. Now let's look at our last problem. Robin shoots an arrow from an initial height of 2 meters. The arrow reaches its maximum height of 20 meters after it has flown a distance of 60 meters. Write a quadratic function to represent the height of the arrow as a function of its distance. So, in order to do this, what we're going to need to do is draw ourselves a little picture. So, here's Robin. And he shoots his arrow to a maximum height of 20 meters after it has flown a distance of 60 meters. Now, remember we start out at 0, 2 because we had an initial height of 2 meters, meaning 60, 20. Notice this goes from the bottom, not from where the arrow started, meaning our new point is at 60, 20. Then I just plug it in. Y equals a times x minus 60 squared plus 20. So I plug in my values. 2 equals a times 0 minus 60 is negative 60 squared plus 20. Negative 60 squared is 3,600. A plus 20 equals 2, which means 36,600A equals negative 18. Divide 3,600 on both sides, and that becomes 1 over 200, negative 1 over 200, meaning our final equation is y equals negative 1 over 200 times x minus 60 squared plus 20.